Hey everyone, welcome back. So in the previous video, we have learned about the pod status, and today we will learn about the resource request and limit in the Kubernetes. So in this video, we will understand what is the resource request and limit, why do we need them, and what happens when the container exceeds the limit. And we will also do the hands-on to see everything in action. So let's get started. So imagine you have a Kubernetes cluster with 2 worker nodes, and each node has a 4 CPU and 8 GB of RAM. Now you deploy the 10 pods, but you don't set any CPU and memory limit. So the one pod start using too much of memory and other pod becomes slow. And the node run out of memory and the entire node becomes unavailable. So that's why resource request and limit are important. So what is the resource request and limit? So Kubernetes give two settings to control the resource uses for every container. A request is the minimum CPU and memory for the pod needs to run. So Kubernetes guarantee these resources to the pod, and a pod will be scheduled only on the node that has enough available resources. And below is the example for the resource request. And this means the pod need at least 500 millicore of CPU and 256 MI of memory. Now a resource limit is the maximum amount of CPU and memory that pod can use. Kubernetes does not allow the pod to use more than a specified limit. Limit help us to prevent the one pod for consuming all the resources on the node. And below is the example for the resource limit. This means CPU users can go up to 1 core and memory users can go up to 512 MI. Now before writing the YAML file, let's quickly understand the unit. So CPU represents the processing power, and Kubernetes measure the CPU in CPU core and millicore. And here are some common examples. For example, if the container requests 500 millicore of CPU, it means the container need half of the one CPU core. Memory represents amount of RAM available for the container while it running. So Kubernetes commonly use MI, that is MB and GI, that is GB byte. So if the container requests 512 MB of memory, Kubernetes makes sure container get 512 MB of memory available when it runs. So what happens when the limit are reached? So if the container uses more CPU than its limit, Kubernetes slow down or throttle the container, but container keeps running and it is not killed. For example, CPU limit is equal to 1 CPU, and if the application try to use 1.5 CPU, Kubernetes allow only 1 CPU, which can make the application run slower. And if the container uses more memory than its limit, Kubernetes stop or kill the container, and the container will get out of memory error. Kubernetes may restart the container automatically. For example, memory limit is equal to 512 MI, and if the application try to use 600 MI, Kubernetes kill the container because it exceeds the limit. So we will have a 3 demo, and in the first demo we will have a normal pod with a request limit, and in the second demo we will see out of memory killed, and in this demo we will observe what happens when the container exceeds its memory limit and get out of memory error. And in the third demo we will see CPU throttling, and we will observe how the container slow down when it tries to use more CPU than its configure limit. So let's see everything in action on the real Kubernetes cluster. So open the killercoder.com, choose the playground. Now let's verify the cluster. So our control plane and node are in ready state. So let's create the file, press -ia and copy the YAML file. So in this example, pod is guaranteed 250 millicore of CPU and 128 MB of memory, and it can go up to 500 millicore of CPU and 256 MB of memory, but not more than that. Now press escape and :wq and enter to save. Now let's create the pod and check the status. Now our pod is running. Now let's describe the pod. Scroll to the container sections and you see whatever request and limit that we have defined in the YAML file, it's present here. So this confirm Kubernetes has registered our resources setting correctly. Now let's do the cleanup. So we have deleted the resources. Now let's see second demo, that is out of memory error. And for this we will create a file and we will press -i and then paste the YAML file. So in this YAML file, container has a memory limit of 50 MB, but the stress command try to use 100 MB. Kubernetes will kill the container because it exceeds the limit. Now let's see in actions. So press and WQ and create the pod. Let's get the status. Just wait for a few seconds and it will come out of memory error. And you see out of memory error. So let's do the cleanup again. Let's see the third demo and we will see here what happened when the container try to use more CPU than its limit. First create the YAML file and paste the YAML file. So in this example, container is trying to use 2 CPU, but the CPU limit is only 200 millicore. Let's create the pod and let's get the status. And you will see the pod is running. It is not killed like a out of memory killed. CPU throttling does not kill the pod. It just limit the speed. So let's describe the pod. Scroll to the container section. And here we have a limit. Now let's do the cleanup. So let's quickly recap what we have learned today. So resource request is the minimum CPU or memory that Kubernetes guarantee for the container. The resource limit is the maximum CPU or memory that container is allowed to use. Always set a request and limit in the production to avoid the resource usage problem. Key behavior: CPU over limit is equal to pod is slow down but it keeps running. Memory over limit is equal to pod is killed due to out of memory and it may restart. And we can use some commands to create the resources and troubleshoot the issues. So that's everything about the resource request and limit in the Kubernetes. In the next video, we will understand about the replica set in the Kubernetes. If you have any questions, feel free to ask in the comment below. Thanks for watching and I will see you next video.